Alright guys, welcome to another awesome physics lesson, and in this lesson I'm going to show you guys the proper way to calculate net force other than the last tutorial where we just threw a addition sign in between and try to add them together in our heads. This is usually what you do. You use something called a vector addition, basically adding vectors together graphically. Now, let me go ahead and show you guys a graphic real quick, and I don't have graph paper or a ruler or anything, but I'm just going to show you guys the concept, how to do it, and then you guys are going to understand everything else. So let me go ahead and tell you guys a little story. I live next to a couple rednecks, and they thought it would be a good idea the other day if they had a big stump in their yard. This is a stump, and they wanted to get their trucks and push it into a river. And here's the river right here. So they had two trucks. The first one was pretty powerful. It was a Ford F-250. So here's the Ford F-250. Really good drawing of it right here. And they had another little truck. This was a little Ford Ranger. So this little truck was pushing in the stump in this direction right here. And it wasn't bad. It had a force of 50 tons. However, this Ford F-250 was a little bit more powerful. This one had a force of 100 tons. So they weren't physicists, so they called me over and they wanted me to decide if he's pushing on this stump in this direction with a force of 100 tons and this little truck is pushing it left with a force of 50 tons, then where's the stump going to go? Is it going to go this way? Is it going to go this way? Is it going to go this way towards the river? What's going to happen? And I said, listen, rednecks, you need to do something called vector addition. And this is how you do that. Now remember, 50 tons left and 100 tons northwest. So just remember that because I'm about to, well, I guess I have space over here to graph it. So in order to use vector addition, this is what you do. Draw an arrow that's pretty much, well, if this is 50 tons, draw an arrow that's 50 centimeters in this direction. Now, if you have a force of 100 tons in the northwest direction, draw an arrow connected to it that's 100 centimeters in the northwest direction. So again, if your force is twice as strong, make sure your arrow is twice as long. Okay? So you see this? Good. So what we're about to do is the next step is to connect these head to tail. So you see how both of these arrows' heads are touching? What we need to do is take the tail and move it over to the head of this arrow. So again, we have our original arrow that's 100 centimeters long, and this would represent the force of the bigger truck. Now what we need to do is take this arrow and take its tail and move it to the head of the other one. Now whenever we do that, we have both of our arrows that are both facing in the same direction still, but now they are tied together. So now what we need to do is start at the tail of the first one and connect it to the head of the second one. So this is our new arrow. Check it out. Now, I am not quite sure depending on the angle of this, but I'll just make a guess and say it's 130 centimeters in this direction right here towards the river. So basically, to calculate net force, that is what you do. Whatever the forces are, you need to draw it to scale the size of your arrows. For example, if you have a 50 ton to 100 ton force, you can either draw this one 50 centimeters and this one 100 centimeters, or you can draw this smaller one 2 centimeters and this bigger one 4 centimeters, as long as they are to scale. Then what you need to do is you need to connect them head to tail and draw a new arrow from the tail of the first one to the head of the last one. And then what you need to do is make a new arrow and take the measurement of that. And that's why it's helpful to have a ruler with you and some graph paper, because just drawing it right here is really inaccurate. But if you had a graph paper, then that is what you do. You actually draw an arrow out and you measure the distance of that new arrow. Now this new arrow, the distance is equal to the force, which would be 130 tons. Now, not only is the distance equal to the force, but the new direction is equal to the new direction of the force. So if we ended up with an arrow this way, then the force would be going this way. So that is how you basically calculate the net force. Add vectors together, measure it, and the distance equals the force, and the new direction equals the new direction of the force. So in this case, they were successful, even though there's some, silly old rednecks. They managed to get the stump in the river because they moved it northwest at with a force of 130 tons. So I don't know if I'm going to show you guys some more vector addition, but we're definitely going to use it later on. If not in the next tutorial, then the tutorial's coming up. So anyways, for now, thank you guys for watching, and don't forget, I know some of these topics are kind of confusing, and if you have any questions about any of them, then please go ahead and ask me on my forum, tnbforum.com. I'll post the link in the description below. But anyways, thank you guys for watching. Don't forget to subscribe, check out my forum, add me on Google+, and I will see you next time.